Today, we're going to talk about a really cool experiment brought to us by Alfred Hubler, a professor of physics at the University of Illinois. We're going to study self-assembling wires made of metal ball bearings, which form emergent structures. First, let's go over the setup. We start out with a petri dish and fill it up with castor oil, then put in metal ball bearings. Castor oil is a bit thicker than vegetable oil and keeps the ball bearings from moving around too fast. The petri dish has a metal ring on the edge, which we apply a negative charge to. Next, we attach a power supply and hang a wire over the top of the petri dish. When we apply a large voltage, electrons get sprayed down to the ball bearings in the dish. Here's a view of the setup. Unfortunately, this isn't an experiment you can try at home. You need huge voltages, which we get from this special power supply. We'll be applying about 20 kilovolts to this experiment. The plugs in your house are 120 volts, so we apply about 200 times the amount of voltage that's in your house. Let's hope nothing blows up. Now let's zoom into the dish. Notice we have all the balls in the center surrounded by the metal ring. You can just see the negative electrode connected to the wire, and you can see the positive electrode hanging down from above the experiment. Now for the fun part. We start applying voltage. At first, nothing too interesting happens. But then we notice some movement. The balls start forming chains, called shooters, that try to reach the outside of the dish. A massive race is on. When the first chain reaches the rim, something amazing happens. It becomes a stem and all the other shooters die, and a new structure forms. We can start the experiment over, but instead of starting all the balls in the middle, we can group them towards the sides in clumps. What will happen this time? Here we see many stems form and compete with each other for balls. They sway back and forth, picking up new recruits and sometimes battle with their neighbors. It turns out that self-assembling wires have some really cool properties. Some metrics are very predictable and others are not. For example, whenever you do this experiment, you find that the balls that end the chains make up 22% of the population, balls that are branching points make up 22% of the population, and the rest are connectors. This is always true, even if you change the size of the balls or the number of the balls. Other metrics are not repeatable, like the number of stems. This system reminds us of living trees because we know what the final structure will look like even if we don't know the exact location of all the beads. This system has a lot to teach us. It heals broken branches, self-organizes, and can even be taught to play a simple game of Tetris. We see complex dynamics arising from local interactions and emergent structures that are sensitive to initial conditions. Be sure to check out Dr. Hubler's paper, along with his website, for other amazing experiments.